Hello, this is Scott with Sam Freeman. This is the ISD1 Assignment 2 solution to making a mixing desk at high speed. Myself, Scott, I actually did the coding that you're watching on screen. Sam is the ISD2 tutor.
Hello.
Who's quite kindly volunteered to contribute to this as well. So it's already kind of underway in the background, so we'll just see if things are making sense or not. The key thing to take away from this first part is that we're building this heavily abstracted design, and you'll see that I've taken the key points of the assignment and turned them into a text document just on the side of the screen here. So I don't think I'm going to actually tick them off as I do them, but hopefully you'll kind of see them come together. So at the moment I'm putting together the volume control here just inside my first patch. You'll see the basic volume control. I've also put together a dial as well as a slider because I'm going to be using the B-patcher behavior to use both the two interface items as I want to. And at the moment it looks like I'm putting together the sort of panning control as well.
So we've got one input so far, that's going to be the audio input, and then we've got three GUI objects, the slider and two different dials.
Yeah, and you'll notice that they're all going to actually work on that one input. So the key element for the user interfaces is that two of them are linked to the one scale, that's the volume control, and the other one is going to be linked together to the for the panning control. The reason for the three items is actually to allow you to reset the pan to center at load time, which is a behavior you'll see towards the very end. So I'm just going to save this first abstraction, this first patch here, and get ready to use it as an abstraction inside a B-patcher. Or am I?
How are you? Load bang to set that to the center, yeah.
Yeah. So that's obviously a little bit of kind of neatness and tidiness. It just makes the interface look a bit more polished.
Of course, the true center of 0 to 127 is a decimal point, but it's close enough for the example. They're in presentation mode, and I guess it's fairly arbitrary where you place these things.
Yeah, literally, I'm just throwing them around the screen. I'm putting them at the top because when it comes to setting the B-patcher offset in a few seconds, it's a lot quicker to work with them all at the same top tier point. So I'll be setting it open presentation mode for the patcher inspector there. And that's the save.
Okay, and the first thing you do if you're going to use abstractions is save the host patch in the same place as the patch you want. So there we go.
Cool. And now I'm going to actually start building the channel patch itself together. So that's the abstraction just being proven as an abstraction. Now I'm going to go for the B-patcher behavior.
So it would have been possible to actually type in the name of the abstraction there, but browsing for it is just as valid.
So the first thing there is I'm setting up this slider, which I'm going to use as a control, then just doing a quick copy and paste. And here I'm going to use the offset behavior to allow me to get the different user interface items.
And we've got three outputs visible on the B patches. So was the leftmost one the slider gain?
The leftmost is the gain, and the middle and the right are the pan arrangement.
Yeah. So using trial and error to set the offsets.
Obviously, you could work it out, go into the patcher and work out exactly where it is, but it just seems to be quicker. You can see we've still got the two there, and one of them is actually centered, which we'll see in a minute. So here I'm just connecting the volume up to the aux send, and then I'm putting the volume down to this bit of code, and I've set the offset, which should bring us up the pan dial interface.
Which should have load band to the center.
We'll see when it arrives.
There it is.
So the key thing to take away from there is the fact that that's the one abstraction loaded 3 times and using the offset behavior just to give us the different user interface items. So I think we're going to see proof that the code actually works, which is maybe something I could have done before we got this far, but you know.
Well, of course, if you had this as 3 separate abstractions, that would be okay, but this is just an incredibly efficient and quite clever way of doing it.
So now we're just going to see if the code works. Obviously we need to turn the DSP on, classic. So there we can see the aux works, the panning's working fine. That's it done there. So we know that the fundamental elements of the actual DSP processing, the MSP processing, and the patch works perfectly fine. Adding in the ADC with a hash argument here because it's a mixer requirement, so I need to have the audio input in. And I'll be using the hash one inside when I use this again as another abstraction. think we'll be setting up the presentation mode here.
So you might have had comments already made at this stage, I think, but I guess you're going to put them in later.
Yeah, commenting something you should definitely do lots of.
Well, I mean, obviously the workings of this, because it's speed patching, is not going to be annotated, but in some respects, your interface, you're going to need to tell them which is which.
Yeah.
Got the sends sorted out there.
So I'm using the global sends, which I'm deliberately going to use globally across all the channels that I'm using. So it makes it nice and quick. It's going to save me a whole load of patching time. Which, when you're trying to do it as fast as physically possible, is a key thing to save. Setting the open presentation mode. It looks like it's going to be another classic Scott interface coming up, which is good to see.
Oops, now we've got our third level of patching.
Just setting the argument there for the ADC. So we've got audio channel 1 coming in there.
Duplicate that, and you can change the arguments.
So it's a point to remember that 1, 2, 3, 4 are kind of arbitrary. The fact they're 4 different numbers means they're going to respond to 4 different inputs from the audio interface. The appropriateness of the numbers could be changed, or you could remap them inside the max environment if need be.
Yep.
So what I'm going to do now is get the reception points for the send. And I've got the send tildes in place, so I'm going to swap them for the receive tildes.
It's always a good idea to copy and paste send and receives. Then there's no risk of typing the name wrong.
If you've made a silly typo in the send, at least it's reflected in the receive, isn't it?
Yep.
It's a bit of a pest of a bug to spot as well, isn't it? When that kind of thing happens.
Okay, so the auxiliary aux send is received up there, and left and right are received below.
Yeah, so here I've just made a quick change of mind, and rather than having the aux send in the main patch and pushing it for an inlet, I've decided just to dump it into the effect itself, in the effects unit itself. That could be quite neat actually if I was going to have some sort of dynamically loading effects panel or something like that, which is beyond the scope of what we're doing here, and you're going to notice that I'm just literally about to throw together the most boring effects unit you've ever seen. It's a delay time of up to, 1 second at the current sampling rate. I'm going to throw an interface, the little user interface object together there. For the purpose of the assignment, obviously the interface is, the effects unit isn't particularly significant really. It's just, it's more the command of the send and receives and understanding the sort of structure that's required to put that in place. So that's it.
Proof of concept.
Yeah, definitely.
And getting the audio going to the right places is at this level more important. You can fill in the gaps in between.
So also you should remember that while there isn't a volume control for the effects return, because I'm controlling the effects send volume from within the channels, I can essentially just keep use that to control the return volume if I want to, which is quite common behavior on a lot of mixing desks anyway, especially of a smaller size like this.
And the aux send in the strip is post fade also, so yeah, you've got control there as well.
So in many situations, in actual fact, I'd probably be looking to put gain on the aux, the aux coming back into the main mix anyway.
But that's all part of the fact that your aux processing would be more complicated than one object with one dial.
Yeah, which is what we're seeing here. So it's a, So, and again, I'm saying putting the effects into an abstraction and then using it as a B-patcher is probably overkill when you consider the scope of the effect itself. But if I was to go for something bigger, more complicated, something that could dynamically load, I'd be more interested in something more complicated than that.
Okay, so we're back in our 3 types of gain abstraction. adding an extra inlet. What's that going to be for?
I think this is going to be for the stereo link. So this is the quickest way to kind of, well, in my mind, this was the quickest way I could do this without having to start to monkey around too much with the patch. So I'm going to use that as a link so I can have a slider controlling 2 of these at a time, which will allow me to change the volume, which will allow me to build a stereo fader really quickly. Here, see that I've just used the abstraction twice in a stereo fader to do it. Yeah, so that's the receive left, receive tilde left, receive tilde right audio being pushed into there, and I'm just going to use a slider now into the right hand inlet, which will provide me the gain control globally across those 2 there. In the ultimate abstracted design, there's definitely an argument to say this should be an abstraction by itself, this entire section with the master return, but at this point, I think, you know, in many ways, like you're doing an assignment, it's just a matter of getting the thing kind of finished, and I'm showing the abstracted behavior off. Remember, I'm reusing my gain patch again now for another purpose, so it's quite, you know, quite useful here. And I'm just doing long messy patch chords now just to get the aux return put into place as well. And we're going to try and tidy it up a little bit. Oh, you see, it makes much more sense that way around now. So this is purely a bit of rearrangement to try and neaten it up. It's essentially probably entirely unnecessary.
I think it's wholly necessary, and I find moving objects around in your max patch is a good way of thinking about what you might do next. You're doing something, you making sure that everything makes sense. You like subconsciously checking for errors, and by the time you finish arranging it, you know what you're going to do.
Yeah.
That's the next step of development.
So in terms of the assessment, that's as effectively at the kind of the pass sort of level here now. We've done all the basic sort of stuff. To be fair, it's probably a reasonably strong pass. I'm going to go and revisit the mute solo behavior now in a minute just to add it on. But essentially, what's here is, you know, what's here would have been a sort of pass, situation. With the mute solo, you're about when we get into that, you're about to see a couple of tricks which really simplify it and will, you know, hopefully encourage you for this here. So I'm just going to put some pre-fade, you know, the pre-stereo control faders meters in here so I can see what's coming off the channel strips, because I'm going to run a little test on the channel strips now just to check everything's working as they should do. So hopefully we'll see this now. There we go. So that's the gain and the pan controls working fine there. And that's the aux end there as well. And it's important to note that I can make these kind of assumptions. You notice I'm just checking things are working now because I know that the channel strips work and they're abstractions of each other, so therefore...
If it works in one, it works in them all.
So the real thing I'm looking for here is just the behavior between them all. So I'm now going to mark off where I think I am with the assignment. Notice it's why it's really useful to have this list, because in all my haste I'd actually completely forgotten to put the audio output in place. So there's the audio output. Just to stress, you won't actually have heard anything from the patch. You're just hearing our voices. It's, you know, it's going to make sine waves. That's, you know, at the moment you just hear a cycle, tilde, or oscillating, so it's not particularly useful or interesting. It's better to see the visual side of it. So as you can see, we've just got mute and solo to revisit now, so I think we're probably heading to them in a minute.
So again, it's going to be an abstraction-based thing. We have a multiplier against the toggle. So when it's on, click the box, we'll send a 1. Empty box is 0.
Yeah, we're going to see just a little bit of maths here just to do the inversion really quickly. I guess it's going to be takeaway 1 and times by itself.
You could also have used the logic operation. If you say equal to 0, then if you put a 0 in, the answer to is this equal to 0 is 1. So, and if you put a 1 in, is it equal to 0? No, so you get 0 out. That's
just proof of the code they're working. You could probably have used a select, maybe a select 0, 1, and just use the bangs to drive message boxes. And so there's a million ways of doing that little bit of code. Whatever way you want to do it basically looks fine. Here I'm setting the mute state to 0. That may seem kind of bizarre because obviously the dial's going to set itself up in that situation. The toggle's going to set itself up like that anyway, but it forces the other toggle to move to 1, which means the patch isn't muted by default. So it's making sure the user interface actually reflects the load time code, which quite often is best done by just driving the whole sequence as if it had been clicked on. So that's the purpose of that load bang just added in there. So this is the mute patch.
presentation mode on that.
Yeah, because obviously the only thing we're actually interested in there is the toggle, the actual mute toggle itself. I've done it in yellow, which is kind of a convention, but you know, I mean, it's essentially probably going to save me writing the word mute beside it. Yeah. So here I'm back in my channel strip. I'm going to set up the repatcher, add in the mute one. Classic effort, I forgot to make an open in presentation mode, so back to the patcher inspector.
The patch was visible there, but that's not what we want to see.
Save.
And wherever it is, there we go.
So now it's a matter of just dropping it into the patch, into the right sort of place. I'm going to have to do some repatching here.
Now in Max 5.3 or whatever the latest version is, it is possible to unplug and replug patch cords, which would be a more efficient way of doing it, but this is old school patching we're seeing here.
Old school. I'm just using that slider just to give me the proof that it works. Need the fader, the signal meter even. Let's have a look. There you go, set up in presentation mode. And you'll notice in the background that they've already appeared. So the patch is reloaded. Decided that it's a little bit too far away. Now it looks a little less orphaned. Maybe. Just quick demonstration, does the behavior work? Yes, it does. You can see that after mute switch, mute off, mute on.
If you'd have put the mute toggle under the slider, it would have reflected the signal path as well within your interface.
Yeah. So on my little list, that's my mute done. Now we're getting to solo.
Now this is the tricky one.
Well, actually, it feels tricky, doesn't it? But you'll find here that I cheat entirely, and what I'm going to demonstrate here is using solo with its own dedicated solo bus. So I'm actually going to take all the complexity out of this. So as it comes together, you'll see. But essentially, what I'm going to do is, if I want to solo, I just bypass all the other DSP controls and dump it straight out the sound card, and that allows me to really simplify the stateful side of it. You'll see there's a little bit of code which keeps track of how many solos are on, which you'll see come together in a minute. But essentially, that is the solo. That is the DSP processing that I'm going to use for my solo bus, and here I'm going to generate a way of keeping track of the solo state, which is just what I'm doing here. I'm going to use a select here, yeah.
So we'll be selecting 0 and 1 or 1 and 0. So when you switch the solo on for this particular channel, it will trigger value 1 and send that across that send. And then I'm guessing -1.
Yep.
Next.
And so yeah, you can tell some familiarity with this approach here. So essentially, this gives me the opportunity, and you'll see it come together in a moment. So that if I put a solo, I'm going to send the number 1 somewhere. If I take the solo off, I send the number -1 there. It allows me to add them together. Here, you're going to see me just demonstrate it as a number box for you quickly. Just going to run the save. And you'll notice that I'm actually going to use this as a counter, so I'm just going to use maths to literally count whether the solo state is on or off and use that to control what's going on. It's important to note here, with the solo and the mute, that both of these are going to click under certain circumstances, because I'm not smoothing the line, I'm just literally on-offing. So I could use a line tilder and 10 milliseconds, 20 milliseconds or something to smooth out the ramps. But
that would take about 30 to 90 seconds longer, which adds up.
And we'd run out of things to say if we were trying to talk over that. So, so just see that. So here I'm going to add the solo into the actual interface itself. I'm being a little bit slack here because I'm adding things straight into presentation mode, which generally I try to avoid. But
because if you don't think to go back to your patching mode you're going to go, I guess you're going to have to connect it.
But it just makes things messy. I'm not a big I'm not a big fan of it really. So there we go. That's So for all the people who spent ages kind of putting together an integrated mute and solo, here's the this is the low hassle.
Yeah, the idea of a solo
dirty version.
A solo could be mute everything but this, using your mute abstraction, but this is a circumnavigating the complexity of that.
Yeah, because you notice essentially what I'm going to do is mute the master output. So when you hit solo, you're not going to hear anything but the channels that have been soloed.
So it's a bit like a pre-fade listen on a analog desk.
On an analog desk, yeah. But it provides the exact same behavior of it as a solo. I guess you could argue that you're missing the aux. You would be missing any sort of effects on it, but then, you know what I mean? I'm saying you generally lose the aux effect on a solo listen anyway. So.
And for the scope of the specification here, I think it's...
Yeah, so here's the send solo bus going in. I was just going to plug it straight in, which is... Yep. It's going to disappear. Yep, I thought it disappeared. So we're going to need to put the volume control in, which is the next part of the patch I'm going to look for. So first of all, we're just going to see the solo state. So when I toggle the solo, the master faders, the master meters are gone, and we're just seeing the signal out of the solo there. And showing the mute solo behavior works as well. So now finally, I just need to keep track of the solo problem, because the issue I've got here is if I hit solo, I'll get 1. If I take it off, then obviously it could disappear. But if I put 3 solos on, I only want to take the solo off once all 3 solos have been taken off. So this piece of code that comes in allows me to do this. So we're just going to see the behavior now. So I get 1 minus 1.
For each button pressed on a solo button.
And now it's a matter of a little count, a little bit of maths again, just doing some basic addition and running the counter.
So when a 1 comes in through the send, it is added to initially 0, and then that goes through that number box and to the right hand inlet, which does not trigger an output. So as soon as so now it's got internally the number 1. And as we add them on, when you add minus 1, it takes away.
So as a consequence, we can... The great thing about this piece of code is that it doesn't rely on any... It isn't kind of time-based at all in the slightest. It's a stateful piece of code. You can query that number box and know exactly whether you've got a solo on or off or not. And you don't have to worry about which solo's on or which solo's off. You can have 5 or 6 being on or 5 or 6 being off at the same point. So I've just put the solo send going straight to the sound card. Probably maybe should have put a volume control in there, might be useful, but it's not a major issue really. Here I'm just going to do the actual control on the master volume, and I got a feeling I'm going to use the master slider that I put in place before. Well, let's have a look.
So select 0. So when...
Oh, I get a little bit overexcited here. So I'm actually going to make it so that so it remembers the amplitude that the slider's at. So here the message box is always going to contain the last amplitude that I've dragged the slider to, which is a nice kind of neat kind of approach. Let's see how far I take it.
So when the number of channels that have been soloed is 0, it selects that 0 and will trigger that message box, which is currently empty, but as soon as we touch that slider,
will have a value in it. This is another example of why I probably should have looked into abstracting part of this away now, because you see that I've got this horrific mess. So I've gone from a really neat, elegant start to a fairly horrific mess. Just in this corner here, and obviously some strong use of abstraction would have helped to tidy that up, I think.
and then when you hit solo, will he hit solo? Ah, you've got your you've set it. You've not got the opposite put in place yet, have you? You've got it so that when you unsolo.
So I've got the unsolo marked here. Hopefully we're going to see we put together some of the behavior as the aux is running. So that's me just going through the bits that work. The pan works, the aux send works, you can see that, that's fine. You saw the master volume go here. The solo is going to... There's the mutes, fair enough. What do I think about my solo behavior now? Let's have a look.
So it's appeared, the output has appeared on the solo bus
On the
there
solo
next to
bus.
the easy DAC, but And when you take the solo off, we saw these select 0 bang, but we haven't. There we go.
Here we go. It's okay. It's okay, everybody. It's that's a prime example of why you should check your code before handing it in, because obviously in my haste there I hadn't actually bothered to do this final bit, so I'm now just going to throw it together quickly here for us.
So we're sending this directly to the destination of that slider, of the master gain slider. Obviously, because if we sent that 0 to the slider itself, the select 0 bang would be triggering a 0.
Yeah. And that's just seeing the behavior there that we expected to see.
Well done.
There we go, and that's it done. I guess there's a couple of little bits to tidy up here. I'm going to neaten up in presentation mode. Sam, I'd like to thank you for your insights on this. It's been it's been good. I hope it's been useful for everybody. It'd be great to get some comments back about whether this kind of thing is useful or not.
Yeah. While we've got a few seconds, I will say that when you're making B patches, if you get a new object box, you start typing B patcher, and by the time you've got a few letters in, there's only one object with starting. If you press spacebar and then at for attribute and then name, so if you put B patcher at name, then a gap, and then the name of your patch, then you don't need to go into the inspector to call it up, which if you're doing a lot of things, it can save you a bit of time.
I think we're pretty much there. Setting up in presentation mode.
Very important, really.
And I think that's going to be it.
And a button to switch it on the interface.
Yeah.
That's a good idea.
Now at this point I'm just going back into the channel strip because I've left the cycle in, which was my test, just to check it worked. So I'm going to delete these items that are no longer needed because I know where it's fine. It's done. And I think that's us done there.